Okay, so question number just a minute. $1.25, right?
Yes, sir.
Euro. So if you read the question, they're asking the angle. At what moment the angle is? Now to bring the angle into picture, you have to go back to vector chapter. And in vector chapter, what we do is we use the dot product. So you're supposed to write the dot product of two vectors A dot B. Because if you write A dot B, you can write this as AB cos theta. And here they are asking the V dot acceleration, which you can write as VA cos 45. Because they are saying that okay, at what moment this is 45 degrees. So this will become the V dot A becomes VA by root 2. And the V vector we can write as and similarly A vector we can also write as AX I cap and AY. And then on the right hand side we will take the value, the modulus value. So let's find out. So X is given, no? X is given how much? 80. So how to find the Vx? Tell me. Vx is
dx by dt, which is
A only, correct? And Y is given something simple only, 80. 1 minus alpha t. So you can write as 80 minus A alpha t square. So what is Vy? The Vy will be how much?
a minus a into 1 minus 2 alpha t.
Correct. Is this clear to all of you? Now, to get the acceleration part, you have to differentiate once more the values of Vx and Vy. So how to get Ax?
It is a constant, so it will be 0.
Excellent. Very good. What is Ay?
Minus 2a alpha.
Excellent. So you got Vx, Vy, you got Ax, Ay. Then you can find the dot, no? So Vx A I cap, Vy A. And in case of A, we don't have Ax, we only have Ay, so which is minus 2a alpha j cap. Correct? We missed something. No, fine. This is fine. Now, okay. So now we are done. So the dot will go with together. This will go together, right? So j dot j, what you get here? So in terms of formula, we can write as mod of V, mod of A, and cos 45 because that's given. So let's solve. Minus 2a square alpha 1 minus 2 alpha t equals to, and what is the mod of V? Mod of V will be Vx square plus Vy square, which is and mod of A will be how much? That's simple. Mod of A will be only one term, 2 alpha by root 2, 1 by root 2. So that's done. So 2a alpha gets cancelled completely here. So if we square both sides, minus become plus 1 minus 2 alpha t equals to a square, we can take 1 plus 1 minus 2 alpha t whole square. Okay, into 1 by 2. So 1 minus 2 alpha t whole square is a square by 2 plus a square by 2 into 1 minus 2 alpha t whole square. So we can take it common. 1 minus 2 alpha t whole square 1 minus a square by 2 is a square by 2. I will some mistake. No. Fine. And then 1 minus 2 alpha t whole square turns out to be a square by 2 minus a square. I can just rearrange. And if I take root both sides, so we have plus minus a upon under root of 2 minus a square. So 2 alpha t is 1 minus plus, I mean, of course, a by 2 minus a square. So just last line. So this is very much mechanical way of solving. So 2 alpha t plus minus a by 2 minus. So t not becomes 1 by 2 alpha. Oh. 1.25. And there's something we made a mistake here. Oh, that's a mistake. No? A we missed the a. This is a square. That's why I said something is wrong. Now this will change. When we cancel the term, a was left, no? A is left. I cancelled that also. So what we are getting a square, and now this will become a square by 2, 1 minus 2 alpha t. Whole square is a square by 2. This entirely cancels. So 1 minus 2 alpha t is plus minus 1 only. And therefore, you cannot take 1 minus 2 alpha t. If you take 1, you will get t equals to 0, which is not possible. So we will take minus 1. So 2 alpha t is 2. It is. So got the idea how to do this?
Yes, sir.
If you use the dot product again. Okay. There should be simple way. Let me just check. There should be some simple way of doing this also. So the acceleration direction is fixed, right? So we have you can do it graphically in one line probably. So we saw that acceleration having only y component. So a is this way. Sorry, minus y. This is minus negative number. So it's so the a direction of a is well known to us. This is like this. Now the Vx is positive. We know Vx is positive and constant. This is A. Now Vy can be positive, can be negative. So if Vy is something like this, then only the resultant will be acute with acceleration, right? Isn't it?
Yes, sir.
And this is 45. This is also 45, which is only possible when this component and the y component both are equal. So basically, the x component, the value wise, x component is VA, Vx is A, and Vy is how much? How much we got Vy? A into 1 minus 2 alpha. 1 minus 2 alpha. So for 45 degree, the V vector will make 45 degree eventually only when the both components are equal in value. So y component is negative. So minus of y component, which is positive value, is same as x, and therefore minus a 1 minus 2 alpha t is a, which you can cancel. So minus 1 plus 2 alpha t is 1. So 2 alpha t is 2. So t is, so if you do
Correct, sir.
graphically, it's much easier to solve. If you want to do it mathematically, that's also available. Okay. Rugved, you tell me how many questions you solve?
There are very few.
Why?
I found them a bit hard.
That's fine. That's fine. See, when something is hard, then only we have to put effort, right? Our job is to, make the things which are hard easier by only practicing. So if you wait that a day will come when things will be easier, that day will never come. And let me tell you, the kinematics is the only difficult chapter of class 11th. After kinematics, the laws of motion frictions are much, much easier than kinematics. And the kinematics part, which you're practicing right now, the entire 12th is based on kinematics. So in 12th class, we have less theory, but we have more questions actually. So in 12th, what we learn is the questions variety, and every question will employ kinematics.
Yes, sir.
So you start doing it. I mean, you see, it's like you have to first become mentally strong that, okay, I can do it. So if you think that, okay, it is just aerodov and it is difficult and so I can't do it, with that mindset, it will remain difficult. So somewhere we all need to change the mindset. Okay, aerodov is not difficult. Let me tell you very clearly, aerodov is not at all difficult. Not at all difficult. Okay, next, it's mathematical. So if you ask me what is aerodov, then I say it's a purely a mathematical book which tests your mathematical skill, not the physics. Physics is simple. Next. Tell me, the next doubt.
Sir, 27th.
27. 27 we have done in multiple ways. Like we have done in mathematical tools also. If you remember the quadratic equation, right? 27 we have done already. So a particle moves in plane xy with constant acceleration w directed along the negative y-axis. The equation of motion of the particle has the form y equals to. Now, what is given? What is given? This is the equation. What else is given? The acceleration is w. How to put that into mathematical form? The vertical acceleration is w, right? The downward. So if I choose the coordinate axis upward as y and horizontal as x, what is the downward direction? Minus y.
Yes, sir.
Okay. Now, when you differentiate the first time, what you get is velocity vy. So how to get the acceleration? You have to differentiate once more. So d2y by dt square is given as minus w. Now this is what given to you. Do you realize this?
Yes, sir.
Okay. Find the velocity of the particle at the origin. So we have to find the v at origin. So that's pretty easy, I think. So ay
Yes,
is
sir.
minus
I
w.
think I got it.
Yeah, so you can do it from there.
Sir, I didn't understand the minus W.
Because the acceleration is downward. And d2y by dt square is, we are writing, assuming y as upward, right? So vy means what? The rate at which you move along the y-axis. Okay?
Okay.
Y means upward. We are taking upward as y. So when we have the assumption upward and the reality is downward, we have to put a minus sign to justify the same. Okay?
Yes.
That's a mathematical way of writing. It's just a simple mathematical way of writing. Okay. So this minus is important. Is this clear? Look with minus part is clear.
Yes.
Okay. So now, okay, let me solve it for the rest of you. So dv by dt of vy is. So to find the velocity, you need Vx and Vy both, right? You need Vx and Vy both. So dVy is how much? Okay, I mean, or you can leave this part. This is not required. Just remember this one. Now y is given to you. Can you differentiate twice? Dy by dt is how much from this equation? Dy by dt is how much? Tell me, guys.
A minus 2bx.
No, you are differentiating with x, no? With time, not x. It is not dy by dx. It is dy by dt. So again, if you
0.
remember, you can use the chain rule dy by dx into dx by dt. Correct? And dx by dt by definition is called velocity. Which component of velocity? Dx by dt represents which component? X
Horizontal.
component. Yeah, x. Very good. So Vy is dy by dx, which is a minus 2bx into Vx. Very good. Okay. So at origin means x is how much? At origin, Vy becomes avx. Correct? So what we do is we put 0 in this equation. And the moment you put x equals to 0, you will get the value at origin. So what is the speed of velocity at the origin? So are the velocity or speed? Okay. So how did we can write as Vx I cap, Vy j cap. And the thing is, we don't know the values of Vx and Vy. Okay. So we got the relationship between Vx and Vy, and what else is given? Acceleration. So let's differentiate. So mathematically, if you solve mathematically, it's lengthy, but there are some other ways of solving also. So Vy is how much, guys? Tell me once again. Vy is how much? The answer is Vy is a minus 2bx. The actual answer. A minus 2bx Vx. A minus 2bx Vx. Very good. Multiply this a Vx minus 2bx Vx. Very good. Then differentiate once again. So dvy by dt will be a dvx by dt minus 2b, and we have to use the product rule x dvx by dt plus vx into dx by dt. So this is dvy by dt is called acceleration, which is given minus w, and there is no acceleration. There is no acceleration in the x direction, so this term is 0 actually. And again, this term is 0. So this is 0, and the dx by dt is vx. This will become vx. Oh, so what you can see something interesting. So I'm solving it purely mathematically. I mean, so Vx square is how much? W by 2. That's it. So Vy is how much? If you remember the formula of Vy, the Vy was AVx at origin. At x equals to 0, the Vy is AVx. So we got Vy equals to y square equals to AVx, A square V square, A square W by 2. Because we know Vx square, we know Vy square, so we can find the V, the value. So check the answer, how they have given the answer. This way or a vector form?
So this way only magnitude.
Magnitude. Okay, fine. Is this answer? Can you check?
Yes, sir. The answer is correct.
So what could be the other way of solving? So once you learn the topic called projectile motion, you can solve this with some trick. And the trick is the y we write as a method ax minus bx square, and the axis in the downward direction is w. So later on we come to know that this we can rewrite as, there is a formula x tan theta minus gx square. So g becomes wx square. So wx square by 2u square cos theta. So actually what we are supposed to find is u actually. So we have to compare actually. So if you compare these two equations, I mean, let's say this is the formula which is not known to you, of course. So let's say if you compare, you can see what is a here. So comparing, what you can say, a equals to tan theta.
Theta.
Very good. And what is b here?
W by
W1.
2u square cos square theta.
So what is u square? Because I want u, the initial velocity. U is how much? W by 2b, and cos square we can write as second theta like this. Is it clear? Correct. And the sec theta we can write as 1 plus tan square theta. And tan we know, right? So as we learn more kinematics, this question becomes trivial question. I mean, just a small calculation. But what I'm trying to teach you, the a pure mathematical approach of solving question. I mean, even you don't know a lot of physics, it doesn't matter. So why this question is given in physics? Because we have always choice. We can either use the conventional mathematics to solve, but if you also aware of the physics part, which you will be definitely at the end of this chapter, then we can have the fusion of the two idea and we can get the answer with less effort. Okay, is this clear?
Yes, sir.
So on the right hand side, it's like if you know the formula, it's just a question of matching the terms and getting the answer. All right. So the calculus way I will suggest to learn as of now, because physics part you will learn anyway eventually. And although I have solved, but when you will try to solve, you will find it difficult, isn't it? So what I'll suggest is that everyone solve 1.27 once again without looking at the answer.
So
Can you
I
try
have
now?
found the 24th question.
24th question.
So the D part, how to take out the mean velocity.
Okay, don't worry. I'll tell you. So you solve this question once again. See if you can do it mathematically. Try it out. Try it out. Try to understand the calculus part, the variation and all. How to convert the the language into a mathematical formulation, and see where you are getting stuck, where which part is really difficult for you. So I will help you with that part. Then you can overcome it. And Rugved, for you, it's essential. You have to start right now.
Yes.
See, to solve irodov, the first thing is you have to remove from your mindset that it's a difficult book. It's a difficult question. It's a really trivial book. I would say most part of it is JEE-Mains level. The only difficulty is why people find it difficult, because they don't start with mathematics. It's not because it is a difficult book. Okay, so try once again. I mean, everyone. I want all of you to solve at least once. Write the equation, see where you're getting stuck. Let me know. I'll explain. I'll give you some hint. Again, try. Hopefully, you will get the answer. Got the answer? Now everyone tell me, like where you're getting stuck. In the first question, you have y given and you have an information given that the accession is in the downward direction. So how to convert these two statements into a mathematical formula? So to find the velocity, you need two components, x and y. Why? Because the equation is in y and x, it means there are only two variables, x and y. So because y and x are given together, it means there must be some relationship between the y component of velocity and x component of velocity as well. Okay. And the
Yes,
y
sir, I got it.
component of acceleration is also given as minus w. So you are getting the answer?
Yes, sir.
Done? Great. So Prashansha and Rugved, tell me. Shreya,
Sir, I got the answer.
you got the answer?
Yes.
Are you sure?
Yes.
Can you send me? I want to see it.
Sir, I had one more doubt. Sir,
Yes.
in many of the questions they asked find velocity. So how do we know we have to find the magnitude or in the vector form?
No, in irodov, this is the doubt always. So you can always look the answer first. So before you solve, just check the answer and then try to answer express in that way.
Okay, sir.
Yeah, that's from the irodov. Yeah. Cool, very good. So you solved the irodov. That's great. So next doubt was 1.24 the D part, right? Prashansa, that's your doubt?
Yes, sir. 24th question.
24th. C or D? Which one you said?
For D, the how to take out the mean velocity, I didn't understand.
Okay. So the mean velocity. So we know the mean of anything is the total displacement upon total time. Or if they give you the instantaneous velocity, then integrate with time like this. Oh, great. So what they have given? They have given R. So R is given ATI cap minus BT square J cap, right? Yeah. So you can find delta R, no?
Yes, sir.
What's the problem here? You can don't use this one. Use this one. Mean means average. So you know the average formula. So add t equals to 0, which is the beginning of the journey. R is how much? 0. And add t equals to t. What is R? The formula itself. So what is the average velocity? Tell me. Displacement, which is final minus initial upon time. It is AI cap minus BT J cap, correct? It is clear.
Yes, sir.
Okay. Any other doubt?
Yes, sir. The 35th B part.
25th.
35th. 35.
Okay. Fine. Okay. That's a nice question. A particle moves in xy plane with velocity ai cap. So the first term is the x component and the second term is the y component. So you can also write Vx equals to A and Vy equals to Bx. Okay, fine. Where I and j are the unit vectors of x and y axis, A and B constant. At initial moment of time, the particle was located at the origin because x and y both coordinates are 0. Find the equation of particle's trajectory and the radius of curvature. Okay, radius of curvature is something which you can ignore because that is a separate topic which you will learn later on. Okay. So that is a part of chapter called circular motion. But anyway, I can give you the idea that how to find the radius of curvature is written as mod of velocity whole cube upon mod of acceleration cross v vector. There are many formulas, but this is the better way of getting it. So when you know the velocity and acceleration, we use this formula. Otherwise, we have also something called 1 plus dy by dx whole square power 3 by 2 whole upon d2y by dx square. So for this, to use the right hand side, we need to know the y and x relationship. And that we can find from here because dx by dt is a. So dx is a dt. When t was 0, x was 0, it's given in the question. So x turns out to be 80. The vy is bx, but now luckily we got x. So we can attach b 80 that one. So dy by dt is b80. So dy is b80 dt and then 0 to t and 0 to y. This will give you y equals to ab t square by 2. And because we know y and x in terms of t, we can eliminate t. So we can write t equals to x by a and then substitute here to get the equation of trajectory, which is ab by 2. And to find the equation of trajectory, what we do, we eliminate the common variable. So the first rule is first to find the relationship in terms of common variable, which is time, and then eliminate it. So y turns out to be bx square by 2. And because we got y, we can find dy by dx, which is bx by a, and d2y by dx square, which is b by a. Now you can substitute in this formula, and this will give you answer 1 plus dy by dx, which is bx by a whole square. And this is the db by a simply value. So yeah, this is your answer. That's it. So you can check this. Is this the answer?
One thing, sir.
Yes, so it's the answer.
So don't worry. I mean, this is what you will learn in circular motion. Formula wise, it is this only. The formula is this much only. But how it comes, I mean, what is the logic? I'll explain there. Next,
The 40th.
40th. Okay. A particle moves along an arc of a circle of radius capital R according to the law L equals to A sin omega t, where L is displacement from the initial position measured along the arc. A and W are omega are constants, assuming R to be this. The magnitude of total acceleration of the particle at the point L equals to 0 and L equals to plus minus. Okay. So tell me, Shreya, which all questions you solved? How many you solved in total? So yeah, a particle moves along the arc. So this is L given, right? The displacement, and this displacement is having the formula A sin omega t. So if this is R, this is L. If I join the other end as well, it will form which triangle? It will form
Isosceles.
isosceles triangle, and therefore this angle we can calculate. So we can write sine theta by 2 is L by 2R, correct? So you can bisect this angle, drop perpendicular, then this is L by 2. This is
Yes,
theta by 2, so sine theta by 2 is L by 2 by R. All right. So the L is 2R sine theta by 2, and therefore the dl by dt is 2R, because we are differentiating with time. Theta is a variable, but we need to use the chain rule here. So d by dt of sine theta by 2. So dl by dt we can find from here, because luckily this is given to us. So this is a omega cos omega t. And this becomes cos theta by 2 into 1 by 2 into d theta by dt. So a omega cos omega t is r cos theta by 2, and d theta dt we call omega. So omega we write as oh, this is confusing. This is called omega angular velocity, so let's call it omega naught, because the omega on the left is confusing. So omega naught is how much? Now what they're asking is the magnitude of total acceleration of the particle at the points L equals to 0 and L equals to plus minus A. Okay, so why am I doing this? So the total acceleration we can always find by simply differentiating twice. So dl by dt is called the velocity. So for the total acceleration, we can write as we need to find the vector per mode. So L is the value given. So if you differentiate L, what you get is the rate of change of L will give you the modulus, the magnitude of velocity. This is something wrong. L is the length on the only length. Okay, we'll stick to this one. Okay, okay. L is given. If I can write L in vector form, so how to write L? V equals to omega. So V tangential equals to omega into R. So tangential velocity is we can write as omega naught into R. Okay, that's cool. And omega naught turns out to be how much? A omega. This is a bit challenging now. So tangential velocity turns out to be A omega sec theta by t. Okay, you can leave this question. I'm solving. Okay, for you it's difficult. I will do all the calculation. So Vt we can write first like this. Then to find the tangential acceleration, we can write as V dt by dt. And again, I have to use the chain rule. So it will become A sec theta by 2. Okay, this omega is constant. So A omega. And the differentiation of sec theta is how much? AT turns out to be A omega sec theta by 2 into tan theta by 2 into 1 by 2 into omega naught. And because now we know the okay, so at t equals to 0, what is theta value? So when t will be 0, what is the L value? L is also 0, no? Because L is function of time t, sin omega.
Yes, sir.
Okay, okay. This question becomes easy if we do it for the condition only, but I was trying to derive in general. So because L is given as A sin omega t, so at t equals to 0, the L becomes 0. Okay, anyway, 0. And therefore the AT also becomes 0. And AC we can write as omega naught square R. So AC we can write as omega naught the value. So omega naught we got how much? A omega cos omega t by R cos theta by t. And because AC, AT is 0, so total acceleration is under root of AT square plus AC square. And because AT is 0, so this is only AC. And answer comes A square omega square cos square omega t into R into sec square cos square. So can I test sec square theta by 2? Oh, okay, let me leave it like this. So cos square theta by 2, which you can attach. And 1 minus sine square theta by 2. And sine theta by 2 was how much, guys? L by 2R. Okay, when L is 0, okay, not T is 0. Okay, I made another mistake. Okay. Okay. Any. Okay, so the first case is okay. This is anyway. This is yes, this is- so at L equals to 0, which is A sine omega t. So sine omega t will be 0. Now this is something called trigonometric equation. So sine of angle is 0 when angle is n pi. Like for any value pi, 2 pi, 3 pi, 4 pi, the sine gives you 0. And cos omega t becomes cos n pi. And cos n pi behaves as a oscillating value. It's plus minus 1. So if n is odd, it will be minus 1. If it is n is even, it is plus 1. But if we have cos square, so the total acceleration comes a square omega square by check the answer. Check the answer. What is given? 1.4. So the total acceleration is this one, right? A square omega square by r, right?
Yes, sir.
Okay, I mean, are you supposed to do all these things? No, you can do it in a easier fashion, but you can leave this question for even chapter like circular motion. You can do it there again. But if you want to do it right now, it's tedious. I can understand. The other part is when L is plus minus A. So AT we got was AT we got how much? Yeah. AT we got something really big. A omega sec theta by 2, tan theta by 2, 1 by 2 omega. Right? Okay, remember this value. I will write again A omega. Okay, tell me what was the AT? A omega. Okay, please write down. A omega sec theta by 2, tan theta by 2 into omega naught by 2. Okay. And what is the omega naught value itself? A omega cos omega t. R cos theta by 2. So now if I substitute sec square theta by 2 and then a square omega square and then cos omega t. So a square omega square sine theta by 2 by cos cube theta by 2 into cos omega t up to length. Okay. L by 2r. So at L equals to plus minus a, plus minus a by 2r. So if you write L equals to plus minus a, which is a cos, sorry, a sine omega t. So omega sine omega t is plus minus 1, which means omega t is multiple of pi by 2, odd multiple. Okay. And the cos of odd multiple is always 0. Okay, so the entire AT becomes 0. Oh my god. Okay, that's a proof. Then the A total will be only AC again. So it is coming with same answer. I mean, AT equals to AC again. And AC was how much? Earlier we had this answer. No? Same answer. So you have to just substitute L equals to A. And multiple of pi by 2. Just check the answer. Is it 0? A omega square. There's so many confusion. L equals to A omega, just A sine omega. So for circular motion, this is the displacement given. So this is fine. So if I say this is theta, this is fine. So sine theta by 2 is L by 2R. So L is 2R. Sine theta by 2. And V vector will be like this always. So the total we have to write like this. AC we write as omega square R. Omega means basically you can write d theta by dt. So that is how we write the AC. And for AT, we have to do some more effort. Theta. Hmm. Hmm. So V tangential is dl by dt. No. Okay, I think this is really lengthy. So it is all about calculation. If you're happy with calculation, you can continue. Else you can leave it. Okay. Okay, Siddhant, you can leave this question if you are finding it too cumbersome to calculate. But it is like this one. Next. So I have given everything. Now you can, if you want, you can proceed from here. You have to substitute here to get the exact formula. And then AC formula is simple. AC is omega naught square R. And then squaring and adding, we do the total accession. And then as per the situation, we have to substitute. So not at all an easy job. It looks really cumbersome for mathematical point of view. Next, any other doubt?
Answer all doubts.
Okay. So how many questions I gave? Up to which question?
Sir, up to 40, but you gave random questions.
Yeah, yeah. All right, all right. So we'll come to now simple world. Like this is the difficult part done, and now comes begins the easier world for you guys. So motion in one dimension, and the first part is with constant acceleration. So imagine we have now one dimension means what? What is the meaning of one dimension? So let's say if we have a particle moving like this, is it one dimension motion or two dimension or three dimension?
One dimension.
One dimension. So your dimension is if a particle moves in a straight path, no matter where the path lies in the xy plane, xyz plane, xyz space, if the path is straight line, we call one dimension. That's it. So for any particle moving in a straight path, we call one dimension. And the moment you start moving in a curved path or but in a plane, we call two dimension. And when you have multiple plane, not one plane, so if your motion cannot be confined in a plane, if your motion is exactly in the three-dimensional space where the x, y, and z all three coordinates are changing. So when all coordinates changes, we call three-dimensional motion. Okay. So all three coordinates should change as well as it should not be straight line, then three dimension. Because in three dimension I can create a line, but that becomes one dimension. So a dimension is the path which you trace, nothing to do with the way we represent it. So one dimension is the particle must be traveling in a straight line. Now that straight line may be parallel to x-axis, maybe parallel to y-axis, maybe in between x and y-axis, or maybe in a space like x, y, z, all three values are changing. Okay. So one dimension is clear. What is the meaning of one dimension?
Yes.
So don't take it literally x-axis or y-axis. It could be anything. Just Okay. So for one dimension, okay, we can choose any axis. So for convenience, I am choosing x-axis. Okay. Now don't say or think that okay, x-axis is the only one dimension. It could be any axis. So now imagine we have something like say an object, let's say a vehicle, car, something, truck, trolley, whatever. Now it is very common like mistake that we always get confused between the displacement and position. So we'll come back to the definition of position vector. If you remember, the position vector represents the location of a particle with respect to origin. So if I choose this as origin, now if I call this as t equals to 0, which means when I start the observation, is the object at origin?
No.
Which means even at t equals to 0, it will have some value of x, which we represent by x naught. Okay. Then after some time, let's call t. After some time, let's call t. Now you can see the particle is at some position. Let's call x equals to x, which is the general value. Now, if I ask you what is the displacement here,
X minus X
displacement,
naught.
yeah. So the displacement which you used to write s in class 9th, then now this will become x minus x naught. So now we are going to write position, not the displacement. So now we are not going to use s here. We'll prefer writing x minus x naught. Now, for simple question, let's say if you're solving SC Verma kind of question, even you can stick to the your old method, s equals to ut and all those things. It will not affect the answer. But the thing is, this new way of writing will simplify the mathematical representation. Okay, so when we solve a slightly tougher question, then this new approach is more convenient, but that will come through practice. So in the beginning, you may find it's a not so comfortable thing. Okay, so if I'm writing s, you're comfortable, but if I'm writing x minus x naught, you may not be comfortable. So that is something which you have to develop. So x is called what? Position. X naught is called initial position. Okay. So the terminology which we use is this is called initial position, but this is called position. Now, next thing. If you begin from origin, then the position vector and the displacement both will be
Equal.
equal. Exactly. So it is also possible that the position vector and the displacement vector may have the same value, but that will only happen when you start from origin. But if you start from place not at origin, then the two will differ. So you will come across numericals in which they will ask you displacement and they will give you position vector or position formula. Okay, so those things you will face very soon after 5 minutes. Okay. So once we know displacement, then depending on the way it is accelerating, whether it is accelerating, whether it is moving with uniform velocity, or whether it is moving with non-uniform velocity, whether it is moving with non-uniform acceleration, we derive the kinematical equation. So there is no absolute formula for, I mean, displacement, velocity. No, everything depends on how the acceleration is there. Is it zero? If acceleration zero, it means in one dimension, the first thing is we have the fixed direction. So direction is not an issue. So in one dimension, a velocity will change only its magnitude. Okay. In one dimension, it is the acceleration behavior which will give you different formula about velocity and displacement. So unless you're not sure about the acceleration, don't try to use the kinematical equation. So when we use the kinematical equation, if you remember the derivation, we use kinematical equation only when okay, don't. So the kinematical equation we can use only when the acceleration of the particle is constant or zero. Understood?
Yes,
Only
sir.
for constant a, those equations are valid. The moment you have variable a, or if a having some function, there is no formula for your kinematical equation. You have to rederive from the scratch. So when you say formula v equals to plus at or s equals to u2 plus half t square or v square equals to u square plus 2s or s equals to u plus v by 2 into t, everything which you derive is actually a case, a one particular case which is called constant acceleration. So if you're solving numerical from SC Verma or irodov and you see that a is given as 2, 3, 4, 5, a, b, some number or some constant, go ahead with the kinematical equation. You see a is given as 5t, 2v or something like this. Never ever attempt such question with kinematical equation. Why? Because a is not constant. Then sir, what we can do? You have to go through the basic of derivation, which is calculus. So you know the definition. A we can write as dv by dt or v dv by dx. Think about yourself what you can do and get the answer. So we'll come to those questions as well again, but we have done, in fact, we have done most of it, but let's do the one dimension. So here we talk about the uniform and non-uniform motion. So, okay, what I'll do is I'll give you first one idea of types of motion. A quick review. Types of motion. So how many types of motion we have? So we have uniform motion and we have non-uniform motion. So uniform motion is also called. What is the meaning of uniform motion? Tell me. If
The
something is
constant acceleration.
no, that's the biggest problem. Everyone get confused there only. I'm saying uniform motion. First, we need to understand what exactly do we mean by motion. How we express motion. So we say that if a particle is changing its position with respect to time, then it is said to be in motion. Then what is a uniform motion?
Sir, uniform motion is when a body covers the same distance in the same time period.
So in general, what we should say, same displacement vector in same time interval, however small be the time interval. So because we are talking about the motion in general, so motion in general, we cannot say same speed or same distance. We have to talk about the same displacement. So let's say you turn one step right, then one step left, or one step north, one step south. Is it uniform?
No, sir.
So although you are traveling same number of steps per second, it is still not uniform because the distance is not the definition of uniformity. So what is the meaning of uniform motion? Okay. Sorry guys, yeah. Uniform motion. So motion always refers to velocity. Now, what you happened in your high school, you studied something called uniformly accelerated motion, right? This is what you studied, isn't it? And you thought that is uniform motion. Am I audible to you guys?
Yes,
Yes.
sir.
Yes, sir.
So this is what happened in school. You studied the uniformly accelerated motion and you thought that is uniform motion. No. If acceleration is there, motion cannot be uniform. Acceleration is a way to change the motion. No? Acceleration changes the state of motion. Acceleration changes the velocity. Then how it can be uniform? So first of all, we need to understand, or you can say reconfigure your thought process. Motion is represented by velocity vector. So velocity vector is called the state of motion. So one value of v represents one state. Another value of v represents another state. And if velocity vector is changing constantly, then we say the state of motion is changing constantly. And if the state of motion is changing constantly, we never say uniform, we say non-uniform. Is this clear? So uniform motion means what? If I want to define, so there are two things uniform motion means. Okay.
So is it compulsory that uniform motion will always be in a straight line?
Yeah, it is compulsory. Because when you change the direction, you're no longer the same velocity, isn't it? Because it's a vector quantity. So vector quantity depends on magnitude and direction both, right? So how to change a vector? By changing the magnitude, A, B, by changing the direction. So if you move in a round path, let's say if you are riding a bicycle, you're maintaining the speed somehow, but turning on a roundabout. Is it representing the uniform motion? Yes or no? Is the velocity vector constant in this motion? Tell me guys. When you move on a roundabout, your velocity will be same or variable.
A
Variable,
variable.
Why?
because the direction is constantly changing.
Exactly, because the direction is constantly changing. So it is obvious that the velocity vector is changing. Then the state of motion is not maintained. And so what we call non-uniform motion. The word uniform is attached to variety of things. But when I say uniform motion, then I only talk about the velocity. Okay. So what we can write here is velocity of a particle represents the state of motion. So velocity of a particle represents the state of motion. Therefore, constant velocity only represents uniform motion. So anything which is in any motion in which velocity is not constant for any reason, whether it's magnitude or direction or both, it falls under the category of non-uniform motion. And to define the uniform motion, the rule is if a particle traverses equal displacement in equal time interval, however small be the time interval, then it is said to be performing uniform motion. See, why the word I'm using however small? There is a reason behind it. If I give you large interval, you can manipulate the motion, right? You can move fast, then slow, and then come back to the same value. So you may traverse, let's say if you want to have a displacement of 1 kilometer, and if you are driving a car, then you can travel fast, slow, and still manage 1 kilometer in, let's say, 5 minutes. But the other guy who is also traveling 1 meter in 5 minutes need not to be moving in the same fashion as the first guy, right? So 1 kilometer and 5 minutes is such a huge value that they can have variety of motion. They can keep on changing the motion. Still, they manage to cover the 1 kilometer in 5 minutes. So we would like to decrease the interval to reduce the possible changes. So what we say do is we make it 1 minute. Now in 1 minute, it is difficult to manipulate much than 5 minutes, but it is still a big interval. So we make it, let's say 1 second. Then the chance of making error is, or the non-conformity is now even lesser. But now we have missiles which can move really fast. So 1 minute is 1 second is also large interval. So we have to go to the millisecond. Even in the Faraday race, the winner and the loser may differ by the in the millisecond range. So beyond that, if you go beyond that, then if you talk about the motion of electron, the millisecond is tremendous time, because in millisecond it will make just zillions of rotation in the inside the atom. So we need to go to nanosecond interval, something like that. So theoretically, however small means, even if I reduce the interval to 0 time, almost 0, and if I divide the time into almost 0 time interval, like next tending to 0 interval, and if I see that in every such elementary interval, the displacement is still the same, then I can assure that it was overall uniform. Okay, so the rule is, for uniform motion, it is necessary that not only you should have the equal displacement in equal time interval, but you have to also make sure that this event is true even for the smallest possible interval that we can possibly calculate. Understood the meaning of uniform motion? Is this clear, guys?
Yes, sir.
What is uniform motion? So uniform motion is only velocity. There's nothing beyond that. So if you know that velocity is constant, and when velocity is constant, then direction must be constant. And the moment you make the direction constant, the path will be a straight line. Yes or no? Tell me, guys. Yes or no?
Yes, sir.
So once you fix the direction in space, the path that you will traverse is only straight line. And that is why every uniform motion is by default straight line motion. But the vice versa is not true. Okay. So now anything else is non-form. So here V vector is constant. And here V vector is not a constant. So uniform speed, does it mean that a uniform speed must be uniform velocity? Is it necessary? So tell me which statement is true. Uniform velocity always represents uniform speed as well. Uniform speed always means uniform velocity. Which one is correct? The first or second? Or both? So when I say uniform velocity, do I mean uniform speed also? Yes or no? Am I audible? So when I say uniform velocity, then it will by default refer to the uniform speed, correct?
Yes.
But when I say uniform speed, is it the opposite also true always?
No.
No, sir.
Because you can drive on a curved track maintaining the speedometer value. So the uniform speed may or may not refer to uniform velocity or uniform motion, but uniform motion or uniform velocity both are same thing. So uniform motion and uniform velocity is the same thing. Always refer to the uniform speed, but the vice versa is not. No, but in this case, there are two situations. If velocity is not constant, then the rate of change of velocity, which you call acceleration, which we call acceleration. So if velocity is not constant, then the rate of change of velocity that may be constant, or the rate of change of velocity, even that could be another variable. So we have talked about the jerk and all those things. Do you remember? Okay. So A is dV by dt, which may be constant. When it is constant, we call uniformly accelerated motion. And when even this is not constant, so we call this as non-uniform acceleration. And to solve such question, use calculus to derive the formula. To solve question, use kinematical equation. So now you know what to we used. And when V is constant, then formulas are very simple. So we'll see the formula for constant V. So for uniform motion, the displacement per unit time is same every time, right? So the ds by dt is always constant, correct? So for a uniform motion, the v vector we can always write as ds by dt, dr by dt, and it is fixed. And dr by dt we can rearrange as dr equals to v dt. And if you integrate, the v is a constant, you can take it out. We write delta r equals to simply v delta t. So if the motion is constant, if the velocity is constant, we can write that displacement as velocity into time. That's it. And no acceleration term will come because uniform motion is zero acceleration. Acceleration is a way to say that the state is changing. So when I say a body or particle is having acceleration, I'm saying that okay, its state of motion is constantly changing. Now the change may be constant. The way it is changing is constant. Then we say uniformly accelerated motion, and the way it is changing is not constant. So we say non-uniform acceleration. And to solve such question, the only way is to go back to the definition and derive it from scratch. We'll see that also. Don't worry. So is this part clear? Okay. Clear? Yes or no?
Yes.
Yes, sir.
And if it is uniform, then the average value, instantaneous value, all will be RMS value, all will be same. So for uniform motion, whether you ask average, instantaneous, RMS, all will be same. Clear? So for uniform motion, average, instantaneous, both remains same. Okay. Now, to make a clear distinction, we will talk about distance and speed. What is the distance, guys? So distance is length of the path traversed by a particle. Very simple definition. It is defined as the length of the path. Oh, path traversed by particle. That's very simple. So here we never consider the direction and all. We only talk about the length, the value. And so comes the next term, speed. What is speed? Speed is
Distance traveled in unit time.
correct. So distance traveled in unit time. Whatever you're saying is correct. Or you can say time rate of change of this distance. That's it. So now we again everything will have. So when you try to put something mathematically, you cannot put without saying something. So you have to say which value you want to explain. So we have average speed. What is the formula for average speed? Tell me.
Total distance upon total time.
Exactly. That's a simple formula. Average speed is total distance upon total time. So what is instantaneous? So how to add this? Delta S, or you can simply say that delta, I mean that's S. S we write for distance here. Now you have to understand from context only. And just said we write T for time. So that's the average. So what is instantaneous speed? Instantaneous speed. It is ds by dt, right? The change in distance upon time interval, correct? So ds by dt is called speed, instantaneous speed. This clear so far? I think this is simple. Now, the relation between distance and magnitude of displacement. Can we compare the distance with the displacement? Yes or no? Can we compare the distance with the displacement? Yes or no? Can we compare distance with the displacement? Yes or no? Can we? Am I audible?
Yes.
Am I audible, guys? Yeah. So my question is, can we compare distance with the displacement? Yes or no?
No,
Why?
because one is vector and the other is scalar.
Exactly. Very good. We cannot compare two quantities which are not similar. So That's why I wrote relation between distance and magnitude of displacement. So we can compare the magnitude part, but we cannot compare the vector with scalar. Okay. So the heading is clear why I wrote like this. So relation between distance and magnitude of displacement. Okay. So if we have a curved path, let's say this is a path, and if you go from A to B along this track, so this the distance is the arc length. What about the displacement magnitude? So the line joining the A and B, the length of this segment, will represent the modulus of displacement. So this length we write as mod of delta R. So we can clearly see that distance here is bigger than displacement, modulus of displacement. Yes or no? It is clear.
Yes.
Okay. So is it necessary that the modulus of displacement must be less than distance? Is it necessary? If I choose a path like this, and if I go from A to B, so for straight path, what we can say? The S will be same as, assuming you are moving in the same direction all the time. So from these two, what you can say? S is either more or equals to. So this is what we know. Na? Distance is always more than or equals to modulus of displacement. Is it possible for distance to be less than displacement? Tell me in terms of modulus.
No,
Is it
sir.
possible? No. So when we talk about the finite distance and finite magnitude of displacement, then the distance is always on the bigger or equal sides. It cannot be less. That's impossible. So if you talk about something different, if you talk about the elementary values, let's say if you go from A to B, exactly ds away. Now, what is the modulus of displacement? Is it same or different? Is it same or different now? The dr modulus and ds, can we compare now? And if we compare, then what we can say? Are they going to be same or different? So if you make the value really small, then can we say the distance will be more than displacement to magnitude, or do we need to say they are going to be equal?
Are equal.
All of you agree?
Yes, sir.
Yes.
So one thing is clear that The finite value may have a difference, but the elementary values are always and exactly same. They cannot be different. Is this clear? And
Yes.
that is why if I divide by time, both sides, the LHS is called instantaneous speed, and the RHS is called modulus of instantaneous velocity. So dr by dt is the instantaneous velocity, and then you're taking the mod. So what you can say now that the speed is the instantaneous speed is nothing but the magnitude of instantaneous velocity. So they are equal only when we talk about the instantaneous value, but not in general. So what do we say? So we can put as a note. So modulus of instantaneous velocity is same as instantaneous speed. It's clear. So we cannot comment on velocity, average velocity, and average speed value. No, we cannot comment about those two things. They are entirely different. It is a very unique case that the instantaneous value match in magnitude. It is clear. I hope this is clear, guys.
Yes, sir.
Okay. So now if I ask you what is the meaning of uniform speed? So can we say uniform speed is uniform velocity now? Can we say that uniform speed represents uniform velocity, uniform motion? Can we say yes or no? Hello, guys. Can we say that the uniform speed is also uniform motion?
Yes, sir.
We can say uniform speed represents uniform motion. Is it necessary?
No, sir.
No, sir, not always.
No. Uniform, then what is the definition of uniform speed? I think Rugved can define. The way I define the uniform velocity, if you try to put the same language into this context, you can also define the uniform speed. What will be the definition of uniform speed? Try, everyone. Try this out quickly.
Covering equal distance in equal time.
Yeah, very close. And one more line. However small be the time interval. So if you see that equal distance in equal time interval, however small be the time interval, then we say uniform speed. So what really matters is the distance. But is this the guarantee of uniform motion? No, there is no guarantee. So what you said is correct. Just to rectify this, add one more line and you're done. So if a particle traverses equal distance in equal distances, equal time intervals, then however small be the time interval, then the particle is said to be performing uniform, or said to be moving with uniform speed. I hope this is clear. So when speed is constant, so can we say ds by dt will be constant? So mathematically, what we can write? ds by dt is v. V is the symbol for constant speed. So ds we can write as only v dt. And if you integrate, this will become s. We can call the total distance as s. And because v is constant, we can take it out. So the formula is s equals to vt. Okay. So s equals to vt. So this formula is only true for s equals to vt is only true for what? Either average or uniform. So for uniform, you can write s equals to vt always. And v average is always s by t. So v average is total upon this, and for uniform, everything is same. So we know for uniform, average, instantaneous, all are equal, right? So this is formula s equals to vt. So v equals to s by t. So t equals to s by v. Then you can remember the triangle, the high school method. V s equals to vt. V equals to s by t. T equals to s by v. Anyway, so you know all this answer. So we are going to solve some question of average calculation. Okay. So we'll do calculation of average speed. So how to get the average speed, guys? So average speed is total distance upon total time. Now let me tell you some of the difficulty which we face as a student. Although it is clearly said by the teacher in classroom that this is the definition. When you will try to solve the question, you will not use the definition. Let me tell you. You will start using something or else. I mean, mostly inspired by the kinematical equation. And that is where we get, make the mistake. You stick to definition, apply the definition, you will get the right answer without any effort. If you don't stick to definition, you will get confused. Okay. So if someone is asking what is average velocity, what is the answer? What is the definition? Average velocity equals to what is the definition of average velocity? Tell me. Hello. 1, 2, 3.
Total distance upon total time.
Average velocity beta. Average velocity. Velocity.
Total displacement by total time.
Yeah, it's total displacement upon total time. How difficult is to remember the basic definition? Is it really challenging?
No.
Yeah, it is challenging because there is a biasness in the mindset. And the day you will become unbiased, the day you start listening to things very clearly and start putting things in perspective, everything will be easy. Okay. So the listening is the biggest skill. So once again, average is speed. What is the formula or definition? Average is
Oh,
speed.
total
Total
distance
distance
upon
by
total time.
total time.
Correct. Average velocity.
Total displacement by total time.
Average acceleration.
Change in velocity by time.
Exactly. Change in velocity upon time. What is the meaning of modulus of average velocity or average of modulus of velocity? These two statements are different or same. Modulus of average and average of modulus. How to interpret these two statements? Modulus of average. The second is average of the modulus of velocity. So average of modulus of velocity is called so if I write a line like this, okay, find modulus of average velocity. Find average of velocity modulus. Then so how to interpret these two statements? Tell me. How are you going to interpret these two statements? Tell me. See why irodov is difficult because the language.
Sir, in the first case, we have to find the modulus of the magnitude of average velocity.
Yeah. So once you find the average velocity, then you see in the first case, first you will find the average velocity, and then you will take the modulus. Correct?
Yes, sir.
So average velocity is delta r by delta t. Then take modulus. That's it. Find the average of velocity modulus. So the magnitude of instantaneous velocity is called, what I'm asking is delta of mod of v, I mean not mod of v, find the average of velocity modulus. So average of velocity modulus, I mean what is the average of this, how to write this? You write the velocity, you take the modulus and then find the average, which means mod of v dt, and mod of v is called speed actually. The magnitude of instantaneous velocity we call speed, and speed into time is called distance. So this is called total distance upon total time, and therefore the second term is called average speed. So now if I would have asked the question, find the average speed, that's very easy for you. Now this has become really difficult because of the language. So sometimes you have to be very careful while reading the language also, and break down the sentences into small, you can say, clauses, and try to read in parts. If you read entirely at once, sometimes you will not make sense of the question also. So make sure that you have to play with the grammar also very accurately and interpret in the right way. If fail to interpret, again the problem becomes difficult. So difficulty having multiple phases. Why something is difficult? A, because you are not reading well. B, because of you are not interpreting mathematically in a right way. C, you're using the wrong approach or wrong concept, or maybe a wrong definition in a different place. So also try to, when you try to solve a question, you get stuck. And when you clarify the doubt, make sure that you also analyze that what really went wrong when you were trying. So were you making the definition incorrect, calculation incorrect, the mathematical approach incorrect, the calculation error, the sign error? So these are possible, you can say, scope of error that we as a student we all commit. That's not a big deal. But if you keep on focusing on your error, your mistake, your improvement will be drastic. If you only solve and ask doubt to your teacher, but you don't analyze what happened, you will remain almost same. So we have a very, I mean, legendary chess champion from India, Viswanathan Anand. Have you heard this name?
Yes, sir.
In we call with, I mean, love, VC. So now Viswanathan Anand, I mean, if you read his story, his mother was very much, frequent in, making this habit that, okay, you must write your why you lost the game. So you must write every step. Because when you lose a game, you know that these steps were the reason that you lost the game. So next time you don't play those steps, and he did the same thing. So every mistake he did in his life, he made sure that, okay, he will write in a notebook. And so he was doing 1,000 ways of making mistake, so he can skip those 1,000 ways, and therefore he become the world champion. So the simple rule is, if you only study and don't put effort in analyzing your own mistake, rectification will never come. So that's my suggestion and request as well to all of you. Every time you have solved, let's say 10-20 questions, always give some time to analyze what went wrong. And there is no need to have the specific time of doing that. You can do that in your brain while doing something else also. So keep on analyzing what went wrong, why you were not able to get an answer. And when you read a question, make sure that every statement of the question is right across in your brain. read till, I mean, so many times such that at least the question is in your brain. You need to read again. So if you can hold the question, it's like holding the completely filled water in your hand. If you can really hold entire question in your brain without looking at the question, that is called you have learned how to read a question. So that's called the reading part. I always say to my student, "Padhna likhna seekho," and they laugh because they don't understand what I'm trying to say in the very beginning. You will also laugh. Padhna, the reading habit. Read till everything is in your brain. That's for reading. Likhna, when you are able to convert a definition, statement, a clause into mathematical way. When you know these two things, the rest of the journey is very easy. So most of us are good with calculation, but these two steps, Padhna and Likhna, is very, very important. Okay, so what we generally do, we read two lines from top and then we forget that what is written above. Then we read the bottom. So you have to repeat the process till every line, every clause, and if something is difficult, try to read more. So the only way to improve your, you can say score in examination or increase your performance in any subject is to read with patience. So the more time you spend in reading the question, the less it will take to solve. So the idea is clear. So language is also very important. You have to understand, okay, this is not a simple English. This English is something that you have to decode. So when you learn science, the language should be decoded instead of just, read like a novel. So imagine you're reading a novel, which is your favorite job. You love it, reading the novel. But imagine a novel with MCQs and a multiple choice question and NET question. Now imagine how easy will be to read that novel if after every 2 page you have to solve some puzzle. Okay. So while we read, even you are reading a novel, think what if they can ask, okay, so think that, okay, what kind of question you can create out of this page. So in that way, you will become the writer. So you will get the perspective of a writer, the way questions are developed to test various aspects of concept. So try to develop that mindset. Okay, slowly. Anyway, so let's solve some easy question and then some difficult question. So it's a very typical question, to and fro journey. So let's say you go from some source to destination B, and while going from A to B, the speed was maintained at V1. Now you are moving with uniform speed only for A2. Then at B, you don't waste much of the time. In no time, you turn back and you start traveling, but with new speed V2. Now, the meaning of average, the meaning of uniform, the meaning of non-uniform. If I consider journey from A to B only, the motion is uniform, yes or no? Tell me, guys. So if I consider journey only from A to B, then can we say the motion is uniform? Assuming A and B is a straight line, can we say the motion is uniform?
Yes.
Can we say the speed is uniform? If motion is uniform, then everything else is uniform, no? Because motion is the bigger picture. Okay. So from A to B, the motion is uniform. What about B to A? Is it uniform?
Yes, sir.
Yeah. But if I take the entire journey A, B, A, can we say the motion is uniform?
No.
And that is why we need to find the average. Because when something is non-uniform, then they will ask you what is the average of the entire journey. So find the average speed. Now I'm asking speed of round trip journey. Clear? Question is clear, guys?
Yes.
Now you can clearly see that, okay, I haven't given you something. What I haven't given you? I have given you speed V1 and speed V2, but I haven't mentioned the distance between A and B, right? So I haven't mentioned the distance. Okay, anyway. Now in physics, it's a simple. When something is not given, assume it, proceed, it will get cancelled for sure. So find the average speed of the journey. Tell me, guys. And don't say with your intuition, say after solving, using definition. So first of all, guys, what is the definition of average speed?
Total distance by total time.
So write that statement. First, you write a total distance upon total time. Then, is the distance given to you? Is the distance given to you between A and B or B and A?
No.
So what is the rule? Assume some suitable variable. That's simple logic. This is how we proceed to solve question. If something is not given and if we feel that, okay, that should be given, we assume some variable on our own. That's simple. So have you assumed something? Everyone?
Yes.
So let's say if you have assumed something, what you have assumed? D, X, S, what?
Yes.
S.
X.
X, very good. So what is the total distance now? If AB is X, what is the total distance traveled in the round trip?
2x.
2X. Now, do you know the time? Because you need total time, no? But because speed is constant, can you find the time in terms of X and V for A to B and B to A respectively? Can we calculate the time in terms of the assumption, the variable which we assume? Tell me, guys.
Yes.
So you can find time, no? The total time you can calculate. And once you calculate, substitute in the formula, you will get the answer. Don't apply your common sense because I know maximum time student answer V1 plus V2 by 2. And how many of you are thinking to answer this question this way? So the moment I ask average, many students, I don't know why, but they simply add and divide by 2 because of some biasness. So don't use all those biasness. Just use the definition of physics. Nothing is difficult, I can assure you. I know you can command physics. Just follow certain things.
2x square upon v1 plus v2.
2x square. How to find time to go from A to B? Time
v1
equals
by
to,
x.
oh my God. So now go back to the basic definition. Recall what is the relationship between speed, time, and distance. So distance equals to,
Speed into
Dis-
time.
so time equals to,
Distance upon speed.
what
Speed.
you did, Rugati did, you did opposite, right?
Yes, yes.
Change it, change it, change it, change it. Nothing is difficult. Now tell me guys, if you have got the answer, tell me. Tell me the answer.
2v1 v2 upon v1 plus v2.
Exactly. Siddhant, you got the answer? I hope so.
Yes, sir. Same.
Question, sir, you got the answer?
Yes, sir. Same.
Shreya, you got the answer? Okay. So the same question I can rephrase. See, it's all about rephrasing. If you rephrase, you go from A to B. You go from A to B, and half of the journey, now see, it's all about language. First half of the journey, so a person goes from A to B. The first half of a journey, it travels with speed v1, and remaining half with speed v2. Find the average speed of his journey. Tell me guys, it's the same answer, same question. So instead of going back, you travel half with some v1, then the next half with v2, and your journey is over. So v1 and v2. What will you approach? You can choose the first half as x, the other half is also x. Then what is the total distance, guys? Tell me. Total distance is how much?
2x.
And time will be same, x by v1 plus x by v2. Am I right?
So can we consider the total distance as x and then the first half as x by 2?
Yeah, you can do that also. You can do anything. That's totally okay. Nothing. So I choose something which is easy to write out. That's it. Okay, it's clear. But there's a better way of reviewing. This answer is actually, you can write like this. 2 upon V average is 1 by V1 plus 1 by V2. Do you realize this answer? Yes or no? Do you realize this, guys? This is the same answer.
Yep.
Correct? Can we write like this? Yes or no?
Yes, sir.
So if I give you a question like this, I mean a very simple question, just
Actually, I have a class now.
yeah. Sorry. It's so fast. I mean, just it's 9 o'clock. I just realized. I just saw that it's 12, 20. Okay, no problem. So we'll continue the next lecture. Okay, that's totally okay. All right, guys. So bye and take care. See you in the next lecture.
Bye, sir. Thank you, sir.
After Diwali, we'll try to keep more lecture. More means bi-weekly we can increase one lecture maybe. Because kinematics is a huge chapter, so I want to finish it fast. So it will take at least 13 to 14 lectures, not that, more than that also, only for kinematics. It's a huge chapter. After that, we can finish very fast. Okay. Bye. Take care.